Dear students, in this section we are going to learn how to analyze the cases of medium having the variable refractive index. In some situations, we need to analyze the cases of medium having the variable refractive index, because refractive index depends on the temperature of the medium, also density of the medium. For example, you can take the example of air. As we go up, the refractive index of the air is not constant, it keeps on changing. Why? Because temperature changes with the height. That means the refractive index of the air is also not constant. So in these types of situation, you may be asked to write the equation of the refracted ray. And in this section, we are going to take one illustration to learn this concept. So let us take one illustration. This illustration, due to the vertical temperature gradient in atmosphere, the index of the refraction varies. Suppose the index of the refraction varies as n equal to n naught under root 1 plus ay. Here n naught is the refractive index at the surface, that is y equal to 0, that is road level, and we are given the constant a equal to 2 into 10 to the power minus 6 per meter. Now, a person of height 2 meter, that is person is observing from height 2 meter and he is observing the road. The question is beyond what distance he cannot see the runway, right? You can observe this is the trajectory of the ray in the medium. Because of variable refractive index, the trajectory is not a straight line, it is keep on changing, because we can consider this overall air layer is made of various thin layers of air having a different refractive index. That means the light ray direction is keep on changing. That's why the path of the light ray in the variable refractive index medium is curve. And here our aim to calculate the trajectory of this light ray. So let us make this diagram again and let us assign the point that is the center of road as O, and let us take one point P on the trajectory of the path of the ray. Correct? Now, here we can do one thing. As we discussed, we can consider the overall air made of different layers of having different refractive index. So what we can do, we can make a layer of air which is parallel with the horizontal, that is parallel with the road, and this point P is lying on this surface, that is the thin layer of the air. Let us assign the height of this layer, that is y. That means the refractive index of this layer should be equal to n naught under root 1 plus ay. Okay. Now let us take this point O, and if I draw tangent at this point, this tangent will give the direction of the ray like this, and if I draw normal passing through point O, we can get the value of angle of incident of this ray at this point. This is 90 degrees. Similarly, now come to point P, we can draw the tangent like this, and we can again do one thing, we can draw the normal through this point, because this layer is horizontal. That means normal at this point should be vertical. Let us call this angle is theta I, that's the angle of incident. If we draw this line, horizontal line, we can say the angle made by this ray is the horizontal, say this angle is theta. If this angle is theta, that means this angle of incident should be equal to 90 minus theta. Now, we can use the Snell law now. We know the Snell law. Snell law says the multiplication of the refractive index and sine of angle of incident is constant. And here we know this angle of incident is 90 degree, and here this angle of incident is I, that is equal to 90 minus theta. And at this level, we know the refractive index as n naught. And here this unknown value is n naught under root 1 plus ay. So let us write the Snell law at this point. We can write here n multiplied by sine I equal to constant, You can write n naught equal to, that is the refractive index is n naught, and here refractive index is n naught 1 plus ay, and angle of incident is 90 degree, correct? So now we can substitute the value of refractive index and angle of incident, and here refractive index is this, angle of incident I equal to 90 minus theta, like this, right? You know, sin 90 equal to 1, and here n equal to this, we have substituted the value, and this sin 90 minus theta equal to cos theta. So we can write cos theta equal to 1 divided by under root 1 plus ay, right? Now we can get the value of tan theta from this equation. For this, let us draw a right angle triangle. In this right angle triangle, here if we write this angle as theta, so we can say this side should be equal to, that is the hypotenuse should be equal to under root 1 plus ay, and base should be equal to 1, right? Now using the Pythagoras, we can get the value of this side equal to this square, that is equal to a1 plus ay minus 1 square, that is 1. That means this is equal to under root ay. Now we can write here tan theta equal to under root ay divided by 1, that equal to tan theta equal to under root ay, correct? Now you know this line is making angle theta with the horizontal. That means tan theta equal to under root ay. We can say this point is lying on the trajectory of this curve. So the slope of this line at this point can be also written as dy by dx. That means dy by dx equal to tan theta. Now we can rearrange the term. We can write y term with dy and dx term separately, like this. Now we can do one thing, we can integrate here. If we integrate, we need to integrate on the both side, and we can write the limit of x as 0 to x and here 0 to y. Now the integration of dx equal to x, and here the integration of this, we can take root a as common outside the integral. So it is the integral of y to the power minus 1 by 2, right? So the integration will be equal to 1 by root a, and here is y to the power, because this is y to the power minus 1 by 2. So integration is y to the power minus 1 by 2 plus 1 and divided by minus 1 by 2 plus 1. So this, after solving, we can write here, this is 1 by 2 is denominator, so 2 divided by root a, and here y to the power 1 by 2, right? Now we can again rearrange this equation. This is equal to 2 under root y divided by a. So we got the trajectory of this curve. This is equal to x equal to 2 root y divided by a, right? We can rearrange this equation, we can write in terms of y also. So y equal to ax square divided by 4. Now we know the height of the eye level is 2 meter, and value of a, that is the constant, equal to 2 into 10 to the power minus 6. Now we can substitute the value of y and a. We have written a naught here, that is a naught here, right? So after substituting the value, we can get the value of x, because we know the value of a and y. So this is the value of x, that is the maximum possible distance of the man from road. So after solving, this relation is equal to 2000 meter, that is 2 kilometer from the runway. If man is located beyond this distance, he cannot observe the road, because the eye level of the man will not pass through the trajectory of the ray.